and thank you for joining the eighth and final episode of the FME server webinar series. So my name is, to introduce myself, François Lagagnère. I'm in charge of business development at Consortech, and Leslie McKenzie, who is our technical team leader, will do the most of the presentation. So if you want to go to the agenda. So we'll explain very briefly like who we are, Consortech, industry trends with regards to FME, and the main subject of the presentation, so best practices and use cases with FME and especially FME server. Just briefly, if you would like to ask questions, there's a Q&A section. I can answer you privately or pass your question along to Leslie if time permitting. So today meeting's objective, you'll see it, demonstrate how organizations leverage FME technology through some of our most popular use cases. So we are Consortech. We are a GIS and data integration expert. We're focusing, I won't say solely on FME, but a lot on the FME technology, doing some Esri and open source adjacent project, but really like, once again, focusing on FME, and we are a safe software partner and reseller, the only one with the platinum status in North America. So what we do, we resell the software, provide training, provide project coaching, and also take on project as well. So the genesis of today's presentation, it came from many of our clients who were asking how they could leverage their the usage of FME in their organization. They were client already using it, loving it, and wanted to push it further. So what we did to answer their request or to respond was to review all the project we did, I'd say in the past 18 to 24 months, and we looked at the at trends and pattern, and finally we come up with a better. Now we have like a better picture of how FME is leveraged across organization. So that's the main categories we came up with. And just very briefly to explain like how like I'd say like the natural evolution of FME, it started like, or it starting depending on where you are in your journey. It starts usually with the desktop version to do like ad hoc data conversion, validation, mostly in GIS department. Then what's happening is there's like a switch to FME server, so it is used as a corporate GIS tool, and it can be viewed as a similar move from moving from ArcGIS Desktop to ArcGIS Enterprise. And now what we see more and more, and that's one of the subject of what we will present today, it's more be used as a corporate IT solution. We see more and more GIS department that are tightly linked with the corporate IT. So we're seeing FME being leveraged in solution that cross the departments and application or system. So that's the genesis of this information. So let's jump quickly in the first category. So Leslie, the floor is yours.
Yep. Okay, so we came up with these 4 categories to kind of group together projects that either we had done with clients or that clients had done using FME to try to be able to paint a picture, because we would get asked the question over and over by clients, we're using FME, but we want to know what more can we do with it, or what are other cities doing with it? So that was kind of like where we came up with this. So the first category, we call it growth management, and it's a lot around managing cities in terms of like planning and in terms of like, upper management and subjects like this. So what we did is we thought of what were the pain points, like what were people using FME to address problem-wise. So in the growth management sector, it was population and data and technology growth. So, cities, some of them, because they have increasing population, some of them might not be increasing population, but actually the amount of data they have to manage and the amount of technologies they have to manage have been growing exponentially. So it can also be that we just have more and more data that's backing actually more and more systems, more and more tools to capture data, more field capture, more applications, more smart devices, And so each type of new technology to inspect assets and things like that creates more and more growth as well. So all this growth leads to some difficulties in predicting the city's income, the city's expenses, how much infrastructure do we own, how many assets do we own, how many units are we taxing. So it was really around having a consolidated view of information for management purposes and planning purposes that are coming maybe from a lot of different places. So the project that in this category that I'll present today is the case of East Gwillimbury. So that's a town in Ontario, a small town experiencing rapid growth, and they had trouble finding a way to coordinate information across the city. So they have a lot of houses being moved into, a lot of construction happening, different projects in different places in the city, different developers. And to be able to track all that information, all the services, a house gets moved into and it needs garbage delivered, it needs recycling picked up, it needs snow removal, that street now needs snow removal. So all of these things, come into play. And some of the challenges were that, even though the city is growing, they're not yet necessarily at the point to grow in terms of, staff and infrastructure. So the staff is very small. They have a IT staff of two main people, and one plays the part-time role of shares the role as GIS and IT person. And another challenge was it was difficult to track growth across the city. So when did a house get moved into? How did the other services know that address is now activated or active? So the solution they implemented to try to share this information across the city was by implementing an Esri map development dashboard, showing a status of all the occupation permits that are getting issued on a daily basis, so that they have a running portrait of how many houses in a development are getting completed. And so first was to create an Esri dashboard, and then in the back end of that, there's some FME workspaces that run on FME server that I'll talk about that integrate the data from the permitting application and the GIS application in order to create the information that we're displaying on this dashboard. And then a number of other specialized reports and utilities were developed for other specific groups, statistics for the Parks Department and statistics for upper management, for instance. So on the back end, so what does this system look like? What does the integration of this look like? So on a daily basis, there's a schedule that runs Monday to Fridays that pulls all the building and occupancy and fire break permits from the permits database and integrates it with the GIS data, with the parcels of the planned developments or the developments that are under construction, to have picture being built every day of all the occupancy permits that have been issued. So how far along is a development program? And as well, those same scheduled tasks produce other reports that go to either senior management of the city or the Parks Department. So in addition to this, in addition to the integration of these two pieces of information, the water department actually realized they also wanted to be able to track the development and track their work that was getting done in the field. So when water meters were being installed, they wanted to be able to have that on the development map as well. Where had water meters been installed versus where they need them? So the water department, a process had been added for them that allows them to take the Excel files that get delivered by contractors, put them into a folder, and FME server automatically uptakes them using the directory watcher in order to automatically join that information to a property and place a point on the map for it. So they have like a point representation on each property for each of the water meters that have been installed. All of these processes have these steps of corrective action. So how that works, if I come to the city view version, so the permitting application is city view, and they're using ArcSDE on the back end for their database for the GIS. So we're pulling in the parcels and we're pulling in the permits and doing a join between the information. Now that join is happening based on address data, because that is the way in this particular instance of city view at this city that we're able to join with the parcels. So if there was, if an address had been entered incorrectly, for instance, and so we fail it to have a join, there's an automatic report that's done every day that sends the information to the city. So just to show what does this look like on the back end, because in reality on FME Server, we're working with like two solutions, that you guys have seen in the last webinars, right? We're working with a directory watcher type automation, and we're working with scheduled tasks. And we're working with emails in order to do notifications of when things don't work. So an email gets sent out to the building departments with, if addresses have been found that didn't link to a parcel. So this is kind of what the workspace, looks like on the back end. So we see that, we're pulling information from different places. We're doing a little bit of cleanup of those addresses. We're doing some we're producing some information for the reports. The results of this information is delivered across the town in an efficient and reliable manner. So they're able to have this information updated on a daily basis, whereas before, if somebody wanted to know which properties had moved into, they had to basically ask the buildings department to extract information from the planning application for them. Now everybody has a sort of live view of how the city is growing and what is moved into. The solution is scalable. So even if the development pace increases, it's not really going to impact their ability to push this information around the city and to provide this information in a clean way across the whole city. So the town is also able to scale it by adapting and adding more reports. The water meters were not part of the original project. It was really about providing which properties had been moved into. But as the need for information or as the needs evolved, they're able to scale the solution quickly with little effort. And there's also another benefit of improving the data quality. So these error reports, the data is basically getting validated every day. So we know that we can integrate our data from our planning and our data from our GIS because we're trying to do it every day with the new permits that are getting issued. And so any new problems get corrected very quickly. And so that helps keep the data clean. So if we have other analysis, other integration to do, we know we're starting with a good and solid basis. We're not falling behind on data entry errors because it's being constantly validated. So this is just some screen caps of the results. So this is an example of the map. So the brown parcels are ones that construction permits have been issued for. The green ones are the ones that occupancy permits have been issued for, and the red ones that fire break permits have been issued for, so they're not allowed to construct on those properties. So somebody who might have the mobile application, like somebody who might be in a vehicle, an inspector or something out in the field with a laptop, is able to check and see what the status of a property is that they might be looking at if they're actually driving around on these roads in this new area. This report is a report for upper management, showing how many units are being taxed, how many occupancy permits have been issued, how many building permits have been issued, to give them a very, very high level picture of how things are moving, so they can make some longer term decisions, or they can understand, their revenue situation. And progress statistics for the parks, this is to give the parks the idea of how far along each development project is. Because for them, while the map was very interesting and useful, knowing the actual percentage is what mattered for them in order to be able to enforce some rules, like rules of being allowed to dump or not dump dirt on properties based on how far along the development project is, or being allowed, or having to develop your park and having to build the park so that they can start phase 2. So making sure that either money is coming in when it's supposed to, or new infrastructure like parks are being built as they're supposed to at the right moment. East Gwillimbury got a number of awards and recognition for this project, so we just thought we'd just highlight that. They were very proud of this project. The second subject I'm going to talk about is asset management. So in asset management, we find that a lot of use of FME turns around these sorts of problems, right? They have aging infrastructures in the city, and once they're growing, have new infrastructure as well. And so it's difficult to have sort of a status of the inventory. Where are there gaps in data and information? Which fields are we missing information for? Because some of these inventories of infrastructure started a very long time ago. Maybe not all areas were inspected at the same times. Maybe there isn't a consolidated status that's comparable across the whole city or that's reliable. Maybe there's gaps in the data. Maybe I'm missing, model information or installation year information on certain assets and things like this. So it makes it difficult to plan for compliance of equipment, let's say, and managing the inventory, or increasing volume of data. So increasing volume of data could mean we have a whole bunch of new assets, but it could also mean we just have new sources of technology. Suddenly we have, suddenly we've decided to deploy water meters or new types of smart water meters, or maybe we have smart on streetlights. All these new, or we have new ways of capturing information. You think of the last 10 years, and now there's a lot of, we used to have ortho imagery every couple of years, but now we also have LiDAR we're getting. Now there's driven LiDAR options. There's a whole bunch of way we can collect data, and also we have more data coming in from the field as people use more and more applications like Survey 123 or Collector, ArcGIS Tracker. So all of this just means more information and more data to manage a lot of it. The project we're going to present in this section today is one that was done for a company in Energier, which is they're basically the largest natural gas utility distribution network in the province of Quebec. They manage around 11,000 kilometers of underground pipe network, and to comply to regulations, they actually have to inspect, streamline the geoprocessing, so to have a sort of a real-time analysis of their progress of in the field. And they used the FME server as one of the components to accomplish this. So this large pipe network needs to be inspected on a regular basis. There are multiple programs. So each program is an inspection program to comply to certain regulations. And so one thing is they wanted to avoid redriving the same pipes when they could have captured all the data a single time for multiple programs at once. So they needed to be able to consolidate that information and also track of where they had been, so that they can prove that they, prove compliance, for instance. So where all the vehicles have driven in the day, be able to keep track of which pipes have been driven. So when the pipe has been driven by a vehicle mounted with equipment for gas leak detection, then we consider that pipe has been inspected. Some inspections are done actually on foot, and some of the inspections are done by vehicle, depending on the types of pipes it is, and then where the pipe is, like in type of buildings and stuff. And the planning group needed to be able to see a progress more often, so that they could actually, adjust their plans, and adjust, the field work, basically. So the structure of the solution, it looks like this. So there's multiple components, and FME plays actually several roles here. So here we have a little graphic of their vehicle and what it looks like. They're using a gas leak detection device that has its own data collection process that I'll talk about in a minute. And they're also using ArcGIS for Tracker. ArcGIS for Tracker is not mentioned here because when we started the project, it was right before ArcGIS for Tracker came out, and we had to make a very quick decision if we jimmied Collector to still work or if we went for Tracker. So they're using Tracker to collect the breadcrumbs, and they're using Collector to collect other information along the way during their field work. So they're using this to collect the data, and FME server is being used to actually do the live geocoding. So every minute a process runs to pull all the newly collected points from the tracker data, which is being pushed live to the server, and calculate which pipes had been sufficiently covered to consider them inspected. And so it's basically geoprocessing that's happening on the fly. So the guy in the field can actually see, within a minute where he has successfully inspected, but also internally they're able to follow that from a point of view of management and of management of the field work. So FME's role here is to do the geoprocessing. So it actually requires analyzing the breadcrumb and analyzing the pipe network and seeing which pipes have been inspected. FME also plays a role in pulling in that field captured data. So at the end of the day, when the truck uploads the data that's been captured by the other devices on the truck, FME pulls that data from a directory watcher and pulls that data in and integrates that into the GIS as well. So here, FME servers using a scheduled task in a sort of here FME servers using a directory watcher in a once a day sort of application. And here FME servers acting more in a real-time sort of way. At the end of every day, a report is produced in Excel, doing some statistics, calculating the total number of kilometers driven that day, like covered pipe that day, and pushing that into an Excel file that gets ingested into SAP, which is the application the planning people actually use to plan the work. So FME servers really playing multiple roles here. And there's some monitoring, right? One of the reasons we're using FME server to do this is because at every point here where you see a red X, if a process fails, there's an immediate email that's sent out to the GIS team so that they can actually work through this right away. And then we actually have a contingency plan. So if it fails to run in a minute, we'll recapture that data that was missed in a different process. So we see FME here providing some security as well and making sure that all the parts that are supposed to ran correctly. So for them, they have three main workspaces here. One to calculate the driven and inspected pipes. So one to do that actual geoprocessing. One to collect the gas leak detection data, and one to produce the statistics for SAP. So the results for them, saving costs and time by eliminating paper. So there were still paper and manual processes to figure out where they'd been and where they hadn't been. It was actually still a very old system they were using to track their field work, which allows them now to reduce the duplication efforts in their field collection, reducing travel and optimizing the use of their equipment. And this gives them a real-time picture of how things are moving along in the system. Our third category of usage of FME server is actually around the topic of public safety. So we see FME server being leveraged in multiple ways for public safety, and the one that I'll talk about today is to be able to create views of consolidated and clean address data. So the examples I'll have are not specific to public safety, but having a consolidated and clean set of address data is a really important factor if we want to, for public safety reasons, for all kinds of reasons, either in analysis purposes or providing emergency services, dispatch applications that require addresses, like 911 applications, for instance. Another pain point we see often, lack of clear processes across departments. So, where's the source of address data coming from? And another use, so one is having clean address data, doing some validation, doing integration into other systems. So pushing data for dispatch systems. That's we have a lot of clients who push data to police dispatch, to fire dispatch, in the municipal space quite a bit. So reprocess the data so that it fits the schemas necessary for those applications. Also to do some validation of address data as well. But also, I also see a lot of other uses. One is automated processes to do cross-referencing of stuff. Like, for instance, if we have some sort of emergency scenario when people have floods or different kinds of scenarios like that, sometimes they have to create FME processes that they rerun on a schedule during this emergency to provide quick access to information as the situation is changing, for instance. So I see a lot of that kind of use of FME. I also see other more analytical use, more like a emergency planning kind of use for public safety, meaning as we get new flood zone data, like cross-reference flood zones against parcels. I have clients that do this on a regular basis in order to have a continuous view, because parcels change, they get split, they get divided, they get merged, different things happen, properties change. So it's just to keep that moving picture of properties against things like flood zones and different emergency management and preparedness scenarios. So the two projects I'll present today are two projects that clients did related to address data, because having a clean and consolidated view of address data for emergency services often is just simply related to having a clean and consolidated view of address data in the city in general. So the city of Terrebonne is a city it's a suburb of Montreal. It's the 10th largest municipality in the province of Quebec, at over 100,000 people population, and they only began their corporate GIS program in 2016. And one of the main sets of data that they realized was going to be a critical one to start their GIS, the basis of their GIS, was going to be a clean set of addresses, because they were virtually used in all applications across the city. They're important for emergency services and for dispatch, but there was also a lot of internal requests for which addresses are serviced by which garbage collection zones, recycling collection zones, like snow removal zones, all of these different kinds of, rules and regulations and dispatch areas and stuff like this. And so even within the city internally, there was a lot of requests. So this is just an example of their search by address thing. So somebody can search for an address and find out what all the services that service that address are, for instance. So one of the challenges in building their consolidated address database was they realized that, we can imagine the simple case of single-family homes each having one beautiful, clean, and easy to represent address. There's a lot of cases where we have buildings where we have a point, but we have multiple addresses associated with that building, or we can have multiple points because we have multiple doors of entry, or we might have buildings that are connected together. And this leads to some challenges. So one of the challenges they had is that, they have cases of buildings where they have two addresses associated with this building, but one is on road A over here and one is on road B over here. The problem is that the address on road A is in service zone 1 and the address on road B is in service zone 2. However, if I use the address point on the building to associate the service zone, I won't pick up that address B belongs in sector 2. So what they decided to do was create an address system, a management system that allows them to have both an address point, which would be positioned on the building, or where the entrance is in case of multi-units, and they also have a separate layer that they manage address anchor points, which is an access point from the road. So this is more representative of the alignment with their services, because like in the case of the graphic here. So this means that they can use these address points, these road anchor points, to associate addresses to their services more effectively. So the technical solution they implemented was 3 FME workspaces that they put on FME server. In this case, run on demand. So we see lots of different examples here, some directory watching, some automation, some scheduled tasks, and some on-demand processes. So in this case, to generate road anchor points for the addresses. So one process is to create those dynamically. Another process is to overlay all the addresses in the city with their service areas. So they do a cross-referenced table that allows them to be able to identify for any address immediately what they are serviced by. And this allows them to feed internal applications and processes with that information, as well as feeding the public with that information. And they have another process that allows them to do validation of street segment address ranges. So, kind of like cleanup, like are the addresses of the points, are the address ranges represented, by the point? So validating the address points against the road ranges that are assigned to the road segments, and some different kinds of validations like this. So what this means now is addresses now have 2 physical representations in the city, which allows them to manage services. And they have a good quality of centralized address and street segments. So this value is downloaded to all the municipal services. It means they have a better consolidated view to send to their dispatch applications. They have they're better able to answer questions within the city. The other project I present in this light is the city of Hamilton, who used FME to push data down from their single authoritative address system. So they implemented an application called Go360 to have a single authoritative data source for addresses. But these addresses need to be pushed down to the city to different city applications in a timely manner. So while some can be pushed in an automatic way, sometimes, through an API call, sometimes some processing needs to happen or some manipulation is required in order to be able to push the data to a downstream system. So each system has its own requirements. Some required intersections, some have different ways of representing addresses, and different applications had different data quality in different systems. So just to give an example, this is a graphic they did in a presentation they did on this project, showing where FME comes into play to push addresses down to their different applications, such as permitting or asset management and stuff like this, and to their GIS, for instance. So, there are some technical challenges in these kinds of solutions that we have to use with FME. For instance, if an address is deleted, it has to be marked as expired in Hence and not deleted. So, you have to identify if addresses are deleted. Are there still work orders associated to addresses that need to be retired? There are different kinds of complexities that have to be dealt with. And that's the kind of thing that you're seeing here in this process, where they're taking the deleted records, they're joining them with active work orders to make sure they're not retiring an address that still has a live work order, because that may because that happens, first of all, and it may create some problems in the system, in the application. There are also some complexities related to matching, addresses in different applications. So there was also having to generate IDs to be able to say, well, this address in this system is this address in the main system, because the addresses are not always written the same way or divided the same way into fields. Maybe one system has a single field with the whole address, and another field has it all separated out by street number and street type and road name. So the results for them is FME has scheduled tasks push this new address data downstream to all these different kinds of systems. So we saw two very different kinds of cases related to addresses. One that's more focused on integrating data down to specific systems based on specific requirements. So schema, quality, matching, are we updating, are we replacing, these types of challenges like this. And the other related to quality of the addresses themselves. Is my street segment layer matching my address points? Can I, does the address anchor points, do I get assigned to the correct garbage pickup zone? And, the creation of that address anchor point versus the address building points. So we see FME used in very, very different ways, but that all kind of paint an overall big picture here. And the fourth subject that I'll get into is the subject of public engagement. So when we talk about public engagement, generally speaking, these are projects where, FME is not front and center. Okay, so the pothole management system. So some of the challenges that they encountered: information is entered into portal by the citizens, but also data is captured by the GPS staff, who's also capturing location of potholes. So they had a challenge of transiting all this information collected from different ways and bringing them into their internal work order management tool, which they're going to use a map for, but they also want to be able to re-provide that data back out. What is the status? Has it been assigned? Has it been repaired? So in this solution, so this is we can see where FME plays a role. And so if I explain here, this is the website. The website writes the data into a layer. This is the pothole layer. So that's what nid de poule in French is. For some reason, pothole layers are called chicken nests here. And we have also the field people collecting with a handheld GPS device the locations of potholes as well. So their collected data gets pushed into a folder that FME picks up the data for, and automatically, through an automation, pushes that data also into the pothole layer. So then there's some ArcGIS processes that happen here to help generate the work order management layer, that then the assignments happen and the work gets assigned, and they create a list of potholes to fix, to fill, for the staff, who then fill the potholes and capture with a GPS the potholes that they filled, which then gets reintegrated with FME in order to update the status of those potholes that have been repaired. So that repair status gets pushed back to the work order management layer and gets pushed to another layer, which is the layer of repaired potholes. So FME is playing a role of pushing the data from these different places and the statuses, as well as doing certain backups along the way as well as of some of the data. FME, in addition to this, has an automatic process that runs every week to produce a weekly report of how many potholes. So this is the borough, so the boroughs of the city. How many potholes were reported? How many potholes were repaired? So even if we repair even if we identify 4 potholes, we might repair 15, because once the guys get out there with the truck, they might actually find more potholes to fix. So that's why these numbers might look, different. And they're able to track, how many potholes have been fixed in how many boroughs. This has allowed them to optimize their pothole repair workflow. So the city of Lévis said they saved 23 working days by automating this process. They also improve customer service. So they have 80% less calls related to potholes since 2017, which, for them is a big deal. There are now statistics available. There's some transparency put out there. People are able to see that the city is doing their job and that the city is being transparent about what they're doing on the roads, but also by producing the management of these things, they're able to actually identify where they have more damaged routes. If they're fixing a lot of potholes in certain areas, they're able to identify where there might be some bigger problems going on. The other example is an example from the city of Oakville, and they're using FME to bridge their portal in Salesforce, where they put in service requests with their department level applications. So each downstream, so while all the information gets entered by city staff, at the help desks into a single portal, it has to get downloaded to the appropriate downstream group. So if it's something that needs to go to work order management, it has to go down to the work order management application, or something that might have to go down to the permitting application. So each system, however, a little bit like the case of Hamilton, where each application requires data in a certain way, cases need to be created in these downstream applications in a particular way. They each have their APIs, or perhaps a database record needs to be created. So they each have their particularities and requirements. So this solution is like the Energier solution. This solution is basically a real-time example of the use of FME Server. So FME Server is receiving calls from Salesforce. So as soon as a case is created in Salesforce, a push is made to FME Server, which then dispatches that case down to the appropriate system. So here are a couple of examples of systems that receive that data. So what does the technical solution comprise of? Salesforce uses the FME notification service to push the requests. So FME Server receives a notification call from Salesforce. So Salesforce has a webhook that when a case is made, it pushes a call automatically to the FME Server. FME Server workspaces run and push the data down to the appropriate system. And then FME Server schedules are used to push the messages back up to Salesforce to inform on the status of these cases. So again, we see a mix of FME Server tools here. We have, sort of the notification service being used as the real-time push. We have workspaces that run and that distribute the data. We have scheduled tasks that run and push information back up to Salesforce. So the results for them was the ability to have this real-time or near real-time, depending on what you consider real-time or near real-time application bridge. The solution is scalable. They can add, so the solution they developed, they're able to, and that they're managing, they're able to add, they have, around 15,000 new cases per year in their that get pushed down to their downstream systems. And so that works out to about $12.50 per month. And then a lot of statuses that get pushed back up to Salesforce in return. So to keep the sort of a round trip going between these applications. So FME in this case is kind of being used as a bridge between the applications.
So in fact, we don't have any questions, and we're really 2 minutes away from the end of the webinar. So I would like to thank you all that has participated to this particular webinar, and also to those who participated in the whole series as well. So once again, thank you very much for your time, and stay tuned. We'll launch other webinars on the FME technologies. Thanks.
Thank you.
Thank you, Leslie.